Hello everyone, today we will talk about free fall. The motion of an object moving under the influence of gravity. So a keyword here is gravity. If something moves under influence or moves due to the gravity only, no any other forces, additional forces, then we call this kind of motions free fall. Basically, when you throw something upward, downward, of course it will move under influence of gravity. No other force means, for example, no wind. Yes, no wind, then we call this kind of motions free fall. Only gravity. As you know, gravity is for our Earth is approximately 9.8 meter per second square. And this free fall occurs only in vacuum. What is a vacuum? Vacuum is a place with no air friction. So here it says no air resistance. Resistance means no friction. Of course, in real life it's impossible. In real life we have air in the we have air molecules. So when you throw something, it will influence the friction, air friction. So in real life it's difficult to do this experiment. So in real life free fall is impossible because we have a additional force and we call it air resistance, air friction. In theory, when we solve physical problems for free fall, we usually ignore the air resistance. So this is only in theory. Now let's explain with some details. When you throw a stone, for example, upward, we know that it will come back to the Earth. Why it comes back? Because of the gravity, because of the Earth. Yes, there is a gravitational force, and we shortly call it gravity. And this gravity for our Earth is approximately 9.8 meter per second square. We can round it. Sometimes we say it's 10 meter per second square, approximately. This is for our Earth. For our Earth. So, as if you pay attention to the unit, this is a meter per second square. So this is the acceleration. Basically, we are talking about acceleration. Acceleration. And this acceleration, of course, depends on the size of the Earth, mass of the Earth, size, radius of the Earth, etc. And it was already calculated for us, and it's approximately equal to 10. So it means when you throw something upward, its velocity will decrease by this 10, because 10 is acceleration. You know, acceleration is a change in velocity. For example, this is a surface, ground, and you want to throw something upward with velocity, let's say initial velocity, let's say 30 meters per second. And this is happening on our Earth, so this object will move under influence of the gravity, and it means its velocity will decrease by 10, approximately by 10 each second. So after 1 second, its velocity will be 20, because acceleration is 10, deceleration actually. After 1 second, velocity will be 10. After 1 more second, velocity will be, let's call it V4, and it will be equal to 0. Basically, it will stop. It will stop. So time interval between this each point is 1 second, basically. Basically 1 second. 1 second, and here 1 second. So basically, this stone, this object will stop, or it will reach its maximum height in 3 seconds. What will happen after 3 seconds? Of course, it will change its direction, and this object, this stone, will accelerate towards the Earth, towards the surface. So this is how it works. And this is a motion with constant acceleration, basically. Acceleration is constant. And this acceleration equal to gravity, of course. and this gravity always 10. Near the surface, of course, near the Earth's surface, near any planet's surface, it will be 10. If you go further, I don't know, for example, more than 1 kilometer, 10 kilometer, of course, gravity will be slightly different. But for, I don't know, 100 meter, 50 meter, 10 meter, gravity will be almost same. It will not change, so we will assume that acceleration gravity constant. What does it mean? It means this is a motion with constant acceleration, so you can use previous 3 main equations that we already explained in previous lesson. Let's write it. Let's write them again. Final velocity equal to initial velocity plus or minus at, and here a is a g. You know, when we use plus sign, when we use minus sign, when velocity decreases, minus, when velocity increases, positive sign, yes, in general. So this was the first equation. Second equation, final velocity square, initial velocity square plus minus 2 acceleration times displacement. Displacement, instead of displacement, here we use height, because this is a motion in vertical direction. So we just use different symbol. This displacement, which is for this case, will be height equal to initial velocity times time plus or minus 1 over 2 gt square. So free fall, basically, this is not new chapter for you. As you see, this is a motion with constant acceleration, so basically you can use previous 3 equations, that's all. You need to just practice, and practice. So you need to solve more problems in order to understand it better. Let's solve this simple example. We have a rock is dropped from the top of 20-meter tall building. What is its impact velocity? What does it mean? Drop means just leave it without initial velocity. You are not throwing. You are just leaving, you are just releasing. So basically initial velocity is 0. So we have a building. The height of the building is 20 meter. Yes, 20. Let's call it h, 20 meter. And we have a rock, stone, and it falls downward with initial velocity 0 meter per second because it was dropped. So what is its impact velocity? What is impact velocity? Velocity is that it will hit the ground, basically. For us, this will be final velocity. We need to find final velocity, and this rock will move under influence of gravity. Direction of gravity, of course, downward, and this gravity is approximately 10 meters per second square. So let's solve this problem. Solution. We need to describe this problem. This is a motion with constant acceleration, basically free fall. So we can use 3 equations as we mentioned before. We need to find final velocity. What we have? We have initial velocity, we have a gravity, and also we have a height or displacement, yes? It means we can easily use equation number 2. Final velocity square, initial velocity square, plus or minus 2gh. Final velocity, of course, unknown. Initial velocity is also given 0 square plus, because downward velocity increases, 2 times 10 times 20. So final velocity square is 400. Final velocity equal to 20 meter per second. So its velocity will be 20 meter per second before hitting the ground, or it will hit with this velocity. We can add one more question. After how many seconds this will happen? As you see, velocity becomes 20 after 2 seconds, yes, because each second velocity increases by 10. So after 1 second, its velocity will be 10. After 1 second, velocity will be 20. So it's simple to solve in this way. Of course, you can also use equation, but you will get the same answer. For example, equation number 1. Yes, final velocity, initial velocity plus gt. Final velocity is 20. We just proved it. Initial velocity 0, gravity 10, time unknown. So from here, as you see, time equal to 2 seconds. Another example. So read it carefully and pause the video. Try to solve this problem. then you can watch my solution. So what we have, a baseball is hit so that it travels straight upward. So we have a object flying vertically upward. Straight means straight upward, vertically, after being struck by the bat. A fan observes that it takes 3 seconds for the ball to reach its maximum height. So after 3 seconds it will reach its maximum height. It means it will stop and it will change its direction and it will go downward. Question: the ball's initial velocity. So we need to find initial velocity for this baseball. It's better to draw, and we know that this is a free fall. We are ignoring all frictions, air friction, air resistance. We have a ball throwing upward with initial velocity unknown, and it reached its maximum height in 3 seconds. So time equal to 3 seconds. At maximum height, velocity becomes 0 because this is maximum height. It will change its direction. It will stop. So let's say v2 equal to 0. We need to find initial velocity. I think we can use equation number 1 because we have a time, we have a final velocity, we have a gravity, only one unknown, which is initial velocity. So let's solve this one. Solution. We decided to use equation number 1, plus minus gt, final velocity 0, initial velocity unknown, minus, because when you throw upward it decelerates, velocity decreases, gravity 10, time after 3 seconds velocity becomes 0. So as you see, initial velocity equal to 30 meter per second. And we have a second question for this problem, the height it reaches. So basically we need to find maximum height, this height, yes, unknown. Now we can use equation number 2 because initial velocity we know. So let's write equation number 2, final velocity square, initial velocity square, minus 2gh, final velocity 0, initial 30 square, minus 2 times 10 times height. So 900 equal to 20h. So h equal to 900 over 20, which is 45 meters. So after 45 meters, this baseball will stop. It will reach its maximum height. Next example. Read the question carefully, pause the video, try to solve yourselves, then you can check your final results. So let's read it quickly. A ball is thrown directly downward with an initial speed of 3 meters per second from a height of 30 meters. After what time interval does it strike the ground? So again, it's better to draw the figure diagram. We have a ground here, surface, let's say Earth, and we have a ball object thrown downward with initial velocity 3 meters per second, and this height equal to 30 meters. So after 30 meters it will reach the surface, it will reach the ground basically. And the question is, after what time? We need to find time, after how many seconds it will be at the ground. Okay, solution. What we have initial velocity, we have a height, we have a gravity, and in this case let's write all these 3 equations and let's decide which one will be better for us to answer for this question. So let's start from the equation number 1, final velocity, initial velocity plus gt, because when you throw something downward velocity increases, so that's why we use plus sign here. Second equation, final velocity square, initial velocity square plus 2gh. Third one, height equal to initial velocity time plus 1 over 2 gt square. So let's see equation number 1. Initial velocity given, gravity given, time unknown, and final velocity unknown. So in order to use this equation, first of all we need to find final velocity in order to find time. So this equation is not good at this stage. Now let's go to the equation number 2. Initial velocity given, gravity given, height given. So as you see, you can find final velocity from this equation, and you can go back to the first equation and find the time. Yes, this is one of the methods. I think we can do it. So let's start from equation number 2, because we can find final velocity. Final velocity square, initial velocity is 3 square plus 2 times 10 times 30. So final velocity square equal to 9 plus 600, yes? 600. So final velocity square equal to 609. So final velocity equal to approximately square root 609, 24.67. 24.67 meter per second. So final velocity given. Now we can go back to the equation number 1. Final velocity equal to initial velocity plus gt. Final velocity is 24.67. Initial velocity is 3 plus 10 times time. From here, time will be equal to 24.67 minus 3 over 10. So time equal to 2.16, approximately 16. So after 2.1 second, it will be at the ground. It will reach the ground. So this is one of the ways. Second way, now let's study the equation number 3. Height is given, initial velocity is given, time is unknown, gravity is given, time is unknown. So if we pay attention to this equation, we have only one unknown, time. And it means you can use only this one equation and find time. So let's see, let's try. So let me write it again. Height equal to initial velocity time plus 1 over 2 gt square. At the end we should get the same answer. Yes, same answer. Let's try. But here we have only one equation. So height is 30, initial velocity is 3 time unknown plus 1 over 2 10 times square. So 30 equal to 3 times t plus 5t square. So this is a quadratic equation, as you see. So 5t square plus 3t minus 30 equal to 0. So this is basically discriminant. We need to use discriminant. Let's answer for this question. Time 1 and 2, as you know, when we have a quadratic equation, we expect two answers, yes, two values. Minus b, which is 3, plus minus b square, 3 square, minus 4a c, yes, 4 times a is 5, c is negative 30. Divide by 2a, a is 5. So let's continue. Minus 3 plus minus, here 3 square 9 plus 20 times 30, 609. 609 square root 609 is 24.67 over 10. So first of all, let's use plus sign here. Plus sign, when you use plus sign, 24 minus 3 over 10, it will give us 2.16 seconds. When you use negative sign, it will give us 27.67 divided by 2, so negative number 2.7 seconds. So we have two possible answers. Math says this equation has two answers, but in physics it says that negative value for time impossible, we cannot accept. So time cannot be negative, as you know. So real answer is 2.16, which is exactly the same value which we already calculated by using first and second equations.